Hey everyone. Okay, so we are on lesson 3, unit 7, lesson 3. Notice you have those up at the top right of your page. Each one of these is labeled now. We have algebra and polygons. Okay, so we're going to determine the area and perimeter of polygons when we're given polynomials as dimensions. Instead of using numbers as dimensions, we're going to be given polynomials. This is one polynomial, 4x minus 2, another one, 3x plus 5. Okay, we're going to determine the value of the perimeter and area when they're given the value of x, when x is given. So we're going to take these polynomials, we're going to plug in the value of x. Okay, then we're going to determine the value of x when they give us the perimeter and area. Okay, so there's lots of different ways that we're going to work these problems. Okay, so we're going to really have to think about how we're working these. Okay. All right, so the first thing we have to remember is some geometry. All right, so to find area, we have to know our area formula for a rectangle. Area is length times width. That is an L, cursive L, y'all. All right, so the formula is length times width. Well, 4x minus 2 is our length, and then 3x plus 5 is our width. Okay, so we're going to do area is our length, which is 4x minus 2. And then our width is 3x plus 5. Please remember this for geometry next year. All right. So we have to multiply these. Remember, it's the box method. I've already drawn you a box here. Surely you've gotten that drawn already. We're going to put our 4x minus 2 up here. We have 3x plus 5 right here. Okay. Now, what we have to do is we multiply everything. 3x times 4x is 12x squared. We have 3x times a negative 2 is negative 6x. 4x times 5 is 20x. And negative 2 times 5 is a negative 10. All right. So now what we have to do is we have to take everything out of the box. So we have 12x squared minus 6x plus 20x minus 10. Remember that these two are like terms, right? Okay, so we have this one and this one. 20 minus 16, what is that? What is 20 minus 16? Gosh, y'all. 20 minus 6, not 16. 20 minus 6 is 14, so plus 14x minus 10. That is our area in terms of x. Okay, area in terms of x. That's how you will hear that. As far as the language is concerned. All right. Now, perimeter. What does perimeter mean? Perimeter means to add all the sides. All right. The biggest error I see whenever I see a rectangle is, okay, so we add 4x minus 2 and 3x plus 5. We only see those two, right? So that's all that gets added. Right? But there's 4 sides to this, right? So you have to remember that a perimeter of a rectangle involves 2 of rectangles, so both opposite sides are congruent. So I have 2 of the length plus 2 of the width, right? Okay. So what we're going to do is we're going to take this length and we're going to plug it in for this L right here. So my perimeter is equal to 2 times this 4x minus 2 plus 2 times this 3x plus 5. Okay? All right. So all I do now is I distribute. Remember, we have to distribute. We multiply the 2 times the 4x, the 2 times the negative 2, 2 times the 3x, the 2 times the 5. Don't forget that. You can use the box method. You can distribute whichever one. We're going to distribute here. So we have P is equal to 2 times 4x is 8x. 2 times a negative 2 is a negative 4. Okay, we're done with this one. Do not forget this second part here. This is what happens a lot. Plus 2 times 3x is 6x. 2 times 3 is 6. And don't forget your x. And then 2 times 5 is 10. Okay, not quite done yet, right? I have some like terms. What are my like terms? These two go together, right? I'm just going to highlight them like this, make it a little bit easier. And then these two go together, right? All right, so let's combine those. We're combining them, right? So my perimeter is, what is 8 plus 6? Well, that's 14, so it's 14x Negative 4 plus 10. Flip it around. What's 10 minus 4? That's 6, right? All right, so my perimeter is 14x plus 6. Okay, so we did the hard part, right? All right, so we have actually determined the area and perimeter of polygons when given polynomials as dimensions. So these are in terms of x. So now what we're going to do is we're going to use these terms of x to answer all of these questions down here. Okay? If the value of x is 4, what is the value of the area? So I have to figure out which one of these I'm going to use. Am I going to use area or perimeter? Well, it's asking for area, so obviously I'm going to use the area formula. So area, if x is equal to 4, what is the value of the area? That means plug in the 4 for the x, right? So I have 12x squared. If area is equal to 12x squared plus 14x minus 10, what is the area equal to? Well, we're just going to plug in that 4, right? Instead of an x, we're going to put a 4 in there, square that, plus 14 times 4 minus 10. Well, let's go over here to our calculator. Let's see it over here, right? So we're just going to have a calculator page open. Let's do 12. I'm going to write it just like this. Open parentheses. Put a 4 in there. Go outside the parentheses. Raise that to the second power. Let's see. Plus 14 times 4 minus 10. All right, I'm going to hit enter. It's 238. Yeah, that's my answer. 238. I'm going to change colors here just for impact here. Okay. All right. So now they want to know, what if x is now 1.5? So x is equal to 1.5. What's the value of the perimeter? Now they're asking for perimeter. Okay. So I have x is equal to 1.5. What's the perimeter? So my perimeter in terms of x is 14x plus 6, right? So I'm just going to substitute the 1.5 in for x, right? So 14 times 1.5 plus 6, what does that equal to? Well, I have this calculator over here. I'm going to use it. 14 times 1.5, what's out there, plus 6. Man, this makes life easy, doesn't it? Man, that's 27. Let's take that and put it in our answer here. 27. Okay. Now, what are we going to do? So now it says, if the perimeter of the rectangles is 34 inches, what's the value of x? So what are we looking for now? We're looking for x, and they gave us the perimeter. All right, perimeter is p, right? So let's write our perimeter formula. In terms of x, perimeter is equal to 14x plus 6. I'm going to substitute what they gave us, which is the perimeter, right? They said it was 34. All right, so I'm going to say, I'm going to put an arrow here so I don't get confused. So 34 is equal to 14x plus 6. Ooh, let's use NSolve, y'all. Let's do this. Let's put NSolve. I'm just going to make a different color here. And then we're going to do comma x here. Let's use our calculator and see what we come up with, right? So in our calculator, we're going to do menu, algebra, numerical solve. I'm going to put this in. 34 equals 14x plus 6. We have to tell the calculator what we want it to solve for, which is x, and we have to do that by doing comma x. And we say enter. It gives us the value of 2. So x is equal to 2. All right. Now, one more. All right, so we want to know what the area of if the area of the rectangle is 16 square centimeters. What is the value of x? Okay, so here we go. So we have the area is equal to 12x squared. So we have our formula, our area in terms of x, and we're going to replace what they gave us, which was the area in square centimeters, right? This is the A. We're going to replace the A with the 16, right? All right. So our area is 16 equals 12x squared plus 14x minus 10. Okay, so this looks very similar to what we did whenever we were factoring, right? All right, or, we could use our calculator, we could graph it. So what we're going to do is we're going to solve for 0. Let's solve for 0. Subtract 16 from both sides. We end up having 0 is equal to 12x squared plus 14x minus 26. Now, I don't want to factor that. I'm going to use my calculator and graph this and see what I come up with, right? All right, so let's do Control Doc and add a graph page, and let's graph this. 12x squared. Now, it may be off the page a little bit here, and that's okay. Plus 14x. We can fix problems as we run into them. Minus 26 and hit enter. Oh, no, it didn't. It didn't get off the page. All right. So I need to know where it crosses the x-axis. And it doesn't look like it crosses very pretty right here, but it doesn't matter, does it? Because we're talking about a real world situation, right? Do we have negatives in the real world? In a real world situation, do we have a negative value for x? No. And over here, this is my 0, right? So all of this is negative over here. The only one I care about is this one right here. So let's do menu, analyze graph, let's do 0, let's do click, drag and click, and look. My value for x is x is equal to 1. Let's go ahead and see what this one is just to make sure. Menu, analyze graph, 0, just so we get in the habit of doing it. It's a negative 2.17. Well, we only use this answer. Because it's a real world situation. Because it's positive. And you have to remember those things. Okay. Let me write this. Woo. I can't write and talk at the same time, y'all. All right. So we only use the positives because it's a real world situation. All right. Okay, so that's the end of video 1. I hope you got something from that. I will see you back in video 2. We're going to talk about squares. All right.